So we zoom in into that membrane. These molecules right here, right? That's the chlorophyll. Each of these is a little chlorophyll molecule embedded in the thylakoid membrane. All right? What color did we say it was going to reflect?
Green.
So the chlorophyll is going to reflect the green light. Now, everything else is being absorbed by that pigment. As that sunlight, sun is energy, right? We already said it's the sun's energy, the light energy. As that energy gets absorbed by the pigment, electrons in the chlorophyll get excited, right? When electrons start to get excited, they start to want to move around, they start to want to jump. An electron jumps off of the chlorophyll molecule, leaving pretty much empty space. It's missing one. Good so far? So we've got a jumpy electron and a chlorophyll molecule missing an electron. What's that? Water. Where does the water come from? From the roots, from the ground, right? So the water is now going to come in. Now you're going to see how in that photosynthesis equation where the water gets used. The water is going to come in and it's going to play a role of filling that empty spot. Notice the empty spot is gone. The water molecule separates, breaks apart, and happily gives up one of its own electrons to fulfill the chlorophyll molecule. Chlorophyll molecule, back to normal, right? But the water molecule is now broken apart. What product did I say we were going to talk about?
Oxygen.
What?
Oxygen.
Oxygen.
Oh, look at that.
Oh, look at that. Our lone oxygen will find another lone oxygen from another chlorophyll molecule from somewhere else in the thylakoid, and we'll be able to leave as oxygen gas, what we breathe in, right? So where does the oxygen produced by plants come from?
Water.
The water, right? A lot of people think that carbon dioxide that we exhale out turns into the oxygen that we breathe in. That's not the case. Carbon dioxide is not where the oxygen comes from. The water is where the oxygen comes from. Nick?
Some people say that plants give oxygen.
They do, in small amounts. We're not going to focus on that. We're not going to focus on that. I'll talk with you about that later. So, now we have a broken up water molecule. We have a chlorophyll molecule that's fulfilled again. And we've got this weird electron that's like jumping around out in space, looking for something to do. What's actually going to happen is that these hydrogen molecules and the electron are going to jump over and turn NADP into NADPH, and going to turn ADP and a lone phosphate into ATP. We're going to build some ATP molecules. This is that temporary chemical energy that I was talking about, right? We said that goal was for today was to show how water gets used, sunlight gets used, oxygen gets made, and how it gets turned into temporary chemical energy that will move on to the next stage. So now we have that temporary energy for the next stage. All right, so oxygen from the water is going to join another oxygen and form O2, basically what we're going to breathe in. All right, and our lost electrons turn into those temporary chemical energy molecules that move on to the second stage. What is the purpose of energy? You guys have any idea what the purpose of energy is for, Richard?
Combine or separate molecules.
To combine or separate molecules. It's to break and form bonds, right? So the whole purpose of energy is to either break bonds, meaning you're going to break something down, like you need to use energy to break down your food, because you need to break bonds in your food molecules, or to build bonds, because maybe your body needs to build protein molecules, use energy to make new protein molecules for yourself. All the energy is doing is just breaking bonds, rearranging the molecules, rebuilding bonds. These two energy molecules are going to be used for that in stage 2. Nick?
Wait, it's like actual energy.
Nope,
How do you know?
can't catch it.
How do you know it's there then?
ATP and NADPH are actual molecules. Their easiest way to think of them is like they're the carriers. They're the things that hold the energy and kind of can transport it to where it needs to be released.
So the NADPH and the ATP will be used in stage 2.
Yep, they're moving on. So on our next benchmark, they're going to come back up, and then we're going to show how all of the pieces of that equation fit together. This summary is awesome. All right, it basically shows you what's going in versus what's coming out. We know that the water is going to turn into the oxygen gas, right? If we go back and look at our equation, if we look at our equation, we've got water was used, oxygen was made, sunlight was used, and now we have these two charged molecules to move on to stage 2. Zach?
See H for NADPH, where the hydrogen.
Yes. Yep. Where the hydrogen comes in, yes. Dave?
Where does the ADP and the NADP come from?
Those are molecules that your body has made.
Alright.
Yep, they're just carbon molecules, various atoms, and they're assembled. They're just not of nutritional value. They're molecules that their job is to hold energy, transport energy, release energy. Good? Nobody else?